Pause the video, give these two questions a go yourself first. Okay, so computer A needs to access a website, but they don't have the URL. And they're not allowed to use in this scenario the domain name service, i.e. a DNS. So what can we do? Well, here's the thing. If you know the IP address to a website, you don't need a DNS. So you'll just use the IP address instead of URL, because DNS would turn the URL into an IP address. But we can't do that, so we just need to know the IP address. If we don't know the IP address, we ain't going on that website. Okay, so we need to go through each one of these to say whether or not they're valid or invalid. Well, this has 1 group, 2 group, 3 group, 4 group, 5 groups, 6 groups, 7, 8 groups. There's nothing which is stupid in terms of it's using hexadecimal, nothing above F, which is the maximum we can go. Okay, that's valid. These 2 dots here mean that we can have the right amount, or everything else would be 0 before here. So we've got 1 group, 2 group, 3 group, 4 group, this will be 5, this will be 6, this will be 7, and this will be 8. That's basically what it's saying, which is fine, we can do that. We've got dot, 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 dot. That is perfectly fine syntax for IP version 6. So that's valid. Even though we're using full stops here, that is fine. This one, we've got hexadecimal and denary, we've got the 2 dots, which means that there's groups in here. That's fine, that's fine, that's fine. So 1, 2, 3, 4, and there'll probably be 4 in here as well. So that's valid. Now this bottom one, that's fine, that's fine, that's fine, that's fine, but we're doing these 2 dots again. We can, these 2 dots means compress the zeros, but we can't do that twice. That's a rule of IP version 6. If you see that there, this can't be here, or vice versa. So, invalid. Pause the video, give these questions a go yourself first. Okay, so we've got GoPull, who types in the URL into the web browser. What happens next? Well, the web browser sends the URL to the DNS. So that'll be B. The DNS will look up the correct URL in the table. Then we want the DNS finds the correct IP address, and then it will return it to the web browser. Describe the purpose of an IP address. Well, every IP address is unique. It allows a device to send data to another device. Over a network. Each device on a network, so like in your house, on a network, has the IP address. And there you go. That is the purpose of an IP address. It's unique. It allows us to send data from one device to another device correctly. Correct to Netflix. And Netflix to send it back correct. Pause the video, give this a go yourself first. Okay, so Internet and World Wide Web are not the same thing. So what I'm going to do is I'm going to talk about each one here. Internet, World Wide Web. So Internet is a network of networks all over the world. World Browser World Wide Web is a collection of web pages. I'm going to also say that the internet uses IP that allows us to connect device to another device correctly. The World Wide Web uses HTTP as a protocol, and this is used for sending web pages. Which are written in HTML. The World Wide Web uses the internet. So without the internet, we can't do the World Wide Web. We can't go on websites. We can't go on web pages. Without the World Wide Web, we can go on the internet. We can play games, online games, but we just can't browse web pages. So the World Wide Web is basically, if we have internet, and then we have things like apps which use the internet. We've got online games. We've got web browser, which uses the World Wide Web. Because we have to type in like www.yahoo.com. Without the internet, none of this happens. But we could actually use the internet and not need the World Wide Web. Putting it out there. So these are the differences. Describe the format of an IP version 4 address. So what I'm going to do is I'm going to give an IP version 4 address here. And now I'm going to describe it. Group of 4 numbers between 0 and 255. Separated by full stop. If we turn it into bits, as in using binary, the maximum is 32 bits. All you need is 3 points. You actually get 1 point for showing the IP address. So that's 1 mark, 2 marks, 3 marks, 4 marks, 5 marks. Okay, so here we go. Pause the video, give these 3 questions a go yourself first. This should be really easy. This, any address you want. There you go. That's an example of a correct address. Why do we need IP version 6? Because the number of IP addresses for version 4 are running out. Explain why this would be this IPv6 would be an invalid IPv4. Well, loads of reasons. Number 1, it uses colons. Number 2, too many digits per group. 3, too many groups. Now in IPv4 you could use hexadecimal. It's not often seen, but you could, so I'm not going to mention that. But I am going to mention address, if I turn it into bits, is going to be greater than 32 bits. Pause the video, give these questions a go yourself first. Okay, so true or false? IP address consists of any number of digits separated by a single dot. No, that's false. Each number in an IP address can range between 2 and 255. Correct. IP addresses are used to ensure that messages and data reach their correct destination. Correct. This is A level. Public IP addresses are considered to be more secure than private IP addresses. No, it's the other way around. private is more secure than public. Okay, we've got this URL. We need to give the meanings of each part of the URL. So we've got protocol. Oops. So this allows the transfer of web pages. HTTP allows the transfer of web pages. And tells the browser if it is secure or not. This is the domain name for where the website lives. This is actually the file or the web page which we want. So for example, if I was to do this, this is going to bring up a web page all about Russia. So the web page is russia.html. But it doesn't have to just be web pages. This will load up an image called russia.jpg. So this is a file which we want, which is part of our file path. So we could have a URL which looks like this: yahoo.com/images/russia.jpg. This would be our file path because in a folder called images. This would be the actual file we want to see, which is a picture of Russia. I mean, it's a picture of JPEG. Or and that is music. So it's a Russian song which belongs in the file path sound. This file path could also be called a subdirectory. This is just wanting the actual file. It's not the file path, it's the file itself, or the web page in this case. How do you know it's a web page? Because of .html. Pause the video, give these questions a go yourself first. Okay, so we've got to turn this into hexadecimal. Well, to do that, we've got to turn it into binary first, and then we've got to turn it into hexadecimal. And each bit we need to turn, or each section we need to turn into binary. So let's do 90 into binary. 1, 2, 4, 8, 16, 32, 64, 1, 2, 8, so 0, 1, 0, 1, which gives us 80, 88, 90. Now, if we're going to turn this into hexadecimal, we then split in half there. This will give us A. So I'm going to put A here because we're doing 90 and it's at the end. And this, if I was to reset these numbers, their placeholder values, will give us 5. So 5A is 90. Now 255 is easy to do because 255 is literally 1, 1, 1, 1, 1, 1, 1, 1. We split. This is going to give us F and F because 15, 15. So done. Now let's do 64. So 64, well, we know it's 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. So this half is 0, this half is 1, 2, 4, 8, so it's going to be 4. and then we've got 11. Now 11, let's do this. 1, 2, 4, 8, 16. We don't need to go any further because everything else will be 0. So we know that we're going to have 0 because everything else is going to be 0 of, oops, didn't mean to blow out the 8 after 16. Now we've got 1, 0, 1, 1, that gives us 11. 8 plus 2 plus 1 is 11 in itself, and 11 is B. So there you go, B040FF5A is hexadecimal for this IP address. Explain the format of this IP address. Well, this is IP version 4, where we've got group of 4, 0 to 255, separated by full stop, and max 32 bits. When a user enters a URL into a web browser, the DNS search locates the required resource. Explain how URL and DNS work, basically. So, URL, that's just Netflix, by the way. URL stands for Uniform Resource Locator. It is the, you could say, human address of website, human language input on the internet. So it's where it lives. It contains the IP address. So we're explaining URL. So how does it work? As we know, browser checks cache. It's not there. We then go to domain name server, the DNS. It translates. So, well, before it translates, it checks the database or table. See if the URL is there, and its job is to translate it to the IP address equivalent. Sometimes it's not going to be there, so it passes it on to another DNS. Hopefully it'll be in there. Once it's found the IP address, what's going to happen? It's going to then update other DNSs, previous DNSs update, because it updates it with the IP address as well. So previous updates. Then it passes it to your browser, and now that your browser will add it to its cache, and it can get the IP address now because we've got it, and send a request to the website or web server. Pause the video, give these questions a go yourself first. Okay, let's do question 1 first. Define what is meant by a cookie. Well, small piece of data in text file. My writing is getting worse and worse. I should say text file that is stored in user's web browser and is updated when user is active on website. That's like 4 marks I've just given there. Okay, so we've got, what's the difference between a session cookie and persistent cookie? So session and persistent. Persistent stays permanently on users' hard drive. So they're used to log in to websites, for example. Preferences. Session cookies, stored temporarily in web browser and deleted when browser closes. And again, they could be used for things such as adding to shopping cart. So items you've added to shopping cart. Once you close your browser, those items go. And there we go. Session versus persistent. Explain how cookies contribute to enhanced activity. So basically things what a cookie can do, such as remembering login details, credit card info, We call it hyper personalization, where basically it does like recommendations and things you want, things you've clicked on. So personalized content. It also has user preferences, like if you want dark mode on a website, for example. Shopping cart. So these are just some.